Hi, everyone. Good afternoon and welcome to the session. My name is Louis Wong. I'm a principal product manager for Amazon QuickSight, and I'm joined by Akshay. He's our senior software engineer on the QuickSight team as well. And today we're excited to share with you a couple new capabilities that leverages machine learning within QuickSight called ML Insights. So, show of hands, how many of you are using QuickSight or have tried out QuickSight before? Okay, great. So for those of you who are not very familiar, QuickSight is our cloud-powered BI service. And our focus with QuickSight is making it available to everyone in the organization. So we launched QuickSight probably 2 years ago, and within the last 2 years, we've released more than 100 new features, so nearly one feature per week. And a couple of things that you'll see new that we announced this week include things like, for example, dashboard embedding, which allows developers to be able to embed the dashboards and visualizations that they create within QuickSight directly within their own application. And today, I'm going to share something that we are announcing, that we've announced on Tuesday, which is called ML Insights. And the way this came about is, a lot of customers telling us, hey, as the volume of my data keeps growing, it is becoming more and more difficult to be able to keep up with that growth in data. And due to the nature of, BI in general that is very manual, it is getting out of hand in terms of being able to harness that data for business insights. So we think that, Amazon is a pioneer in the AI and ML space. Using it for business, and with AWS, we've made a lot of that technology available to all AWS customers. Now we're integrating that into our own BI solution with ML Insights that allows customers to get deeper insights into their data. So there are three functionalities that I'm going to show you today. One is called machine learning powered anomaly detection. So you might be thinking, what does anomaly detection have to do with BI, right? Like a lot of you may know anomaly detection for operational analytics and monitoring and security. But in fact, anomaly detection is actually very, very relevant in the BI space, especially for reporting. And I would argue it's even more relevant for BI. And our goal with anomaly detection is to be able to help customers uncover the hidden insights that is available in the data by continuously analyzing across billions of data points in their data. The second functionality that I'm going to introduce today is called ML forecasting. So we're building forecasting directly within QuickSight powered by machine learning. And forecasting is pretty self-explanatory, but the key here is making it really, really easy for even the end business users with no data modeling experience, no ML experience, through just a few point and clicks, be able to do a really, really good forecast on their metrics. And finally, my personal favorite is what we call auto narratives. Right? And the key here is to be able to allow customers to build dashboard that not just has KPIs, bar charts, line graph, tables, but be able to tell the story of their data directly using words within their dashboard, so that an executive, when they come to your dashboard, they can immediately read and understand what is going on without having to spend hours sifting through and trying to understand. So let's start with machine learning powered anomaly detection. With QuickSight, what you'll be able to, okay, so let me back up a little bit here. A lot of challenges that we see with traditional BI reporting is that because the data is so big and keeps growing, a lot of customers just resolve to looking at the high-level aggregates, but a lot of the really interesting insight lies within all the different dimensions that the customers have. But because it is manual today, there's no way for humans to be able to scale that, and customer results are looking at a subset of the data rather than the entire thing. It results in businesses slowly reacting to the business incidents. And there are various anomaly detection tools in the market, but most of them are really targeted towards developers and technical people and not really for a BI use case. So that's what we're trying to solve today with our anomaly detection for BI that allows companies to analyze millions of metrics simultaneously. We'll continuously run it in the background. We'll not just tell you what an anomaly is, what happened, but also do a further deep dive to show you what contributed to that anomaly. You'll get alerts via email saying that there's an anomaly. You can click through it and then land on the QuickSight dashboard to see more details. And there's absolutely no ML expertise needed. So for example, we'll be able to show you for a particular given day, what are all the anomalies that happen. We'll highlight those. And then what you'll be able to get is also a natural language summary of that, saying that, hey, this is the anomaly. This is why we think that anomaly was detected. In this example, for example, you'll see that sales for office supplies in Asia Pacific increased more than 15% above the expected. We'll tell you what contributed most to that anomaly. In this case, for example, the SMB customer segment was the top contributor, and we'll also tell you why that is significant. So because SMB typically contributes to only 30% of total sales, but we saw that, hey, that increased to 58%. That is really, really significant. Next, point and click forecasting. So traditional tools, I'm just going to skip this. Traditional BI tools, if you see, a lot of them provide built-in BI forecasting. But with QuickSight, we are actually leveraging machine learning. And the left side is a traditional BI tool. The right side is QuickSight. And what you'll see is a key difference in terms of, you'll see that they do call out the seasonality in the data. For example, you'll see that in March, September, November, there are spikes, right? And that is captured in most BI forecasting solutions. But with QuickSight, not only do we capture the seasonality in the data, but also the trend. We automatically identify the outliers that are available in the data, and we are able to automatically exclude that so that it doesn't impact the forecast. And Akshay is going to show you how all of that works in a second. And then finally, telling the story of your data through natural language. So typically what happens is you have a dashboard. It has a lot of KPIs. It has a lot of pie charts, bar charts, and tables. With QuickSight now and auto narrative, we can auto-generate a summary of your data, and these automatically updates as your data updates. So it's not like manually typed out, right? And then you have to update it manually every day, every week or so. These all are automated for you so that when your business stakeholders come to your dashboard, they can just immediately read and understand what's going on. So with that, let me pass it on to Akshay. He's going to do a demo for us.
All right, great. Before I start off with the demo, I just wanted to just quickly talk about a couple of points with anomaly detection and forecasting that we have. So with anomaly detection specifically, let's say, all right, you have a few time series, like few hundreds of time series. You can run it through a standard deviation, a running mean, and see how much it is off by, and you can kind of deal with the noise that you see over there. However, when you scale this problem to millions, many millions of time series, and you want to really monitor the health of your business, then it becomes a hard problem. Yes, you will be able to find anomalies even then, but the amount of noise you're going to get in that much data is also going to be a lot to deal with. So it just really becomes a problem to actually filter out the false positives and the real anomalies. What we do with machine learning is to use an ensemble-based technique, which I will talk to you about once I do the demo. As you can see, this is a dashboard that's been built in QuickSight. This is not one of your traditional dashboards that you usually see. As you can see here, you have natural language-based visuals rather than, in addition to all the line charts and bar charts that you see. So for example, if someone in a company is trying to build these powerful visuals using natural languages, you can share this seamlessly with your executives who can really monitor the health of your business by just looking at, like natural language texts. I'll go over a demo where I'll actually construct these visuals for you from scratch. But if you can look at here, number 1, 2, and 3, these are our ML-powered insights. The one over here is based off forecasting. The two over here that you see are based off the anomaly detection that we ran. So I'll go over how you go about configuring these jobs as well in QuickSight. But for now, let's just look at what this really says. This is basically the result of an anomaly detection run. So let's go see what happens here. Explore anomalies. So we're basically analyzing time series data on a particular dimension. In this particular case, we're analyzing this on product and country. right? And in anomaly detection in QuickSight, you have the option to configure thresholds. Thresholds are low, medium, high, and very high, where based on how much of a spike or a dip you're interested in, we'll be able to filter them out easily for you. So as you can see here, these are basically the anomalies that appear on a daily basis in your time series. So what we do here is we take the most recent timestamps, like about 1,000 timestamps from the last known time value, and then run anomaly detection on each one of your dimensions. So in this particular case, as you can see, there were 27 anomalies that were detected on November 22nd. And now QuickSight gives you a breakdown of what those 27 time series categories were. Like, for example, baby products in Russia had a dip over here, as you can see. There's a big spike over here that contributed to an anomaly. There's a spike over here. So as you can see, these are all the callouts that we do. Now, when you have to, so what we really are trying to achieve here is to find the needle in a haystack, right? Like, that's the kind of a problem that we're trying to target. So by randomly looking at, let's take another timestamp, November 1st, and see what really happened here. As you can see, there was a spike here. There was a spike here. We're just getting it to you right there. We're just calling out the anomalies and helping people know that, OK, there's something that's gone wrong, and people can monitor this on a daily basis. Let's go to the other insight that was run. So this is another anomaly detection run on another time series combination, which is time and customer name on a particular visual. So as you can see, November 22nd had one anomaly. As you can see, it kind of spiked higher than expected. So in QuickSight, we just don't stop at just telling, OK, hey, here's an anomaly in your data point, right? The natural question that follows after this is, why is this an anomaly? What contributed to this change, right? Can you tell me more about this point? So what we really do is what Luis explained initially in his presentation is contribution analysis. So you can really click on this point and say, hey, I want to analyze contributions. OK, so this is customer name. You can say, OK, I want to go analyze on product and country and see what really drove this particular change. And if you can see that clothing contributed to almost 95% change that, with respect to this anomaly. These are some of the things that we expose to our customers, wherein they can actually get not just stop at, hey, something really happened, to also answer. Like, basically, we try to help customers to tell a story in terms of what really happened over there at that particular point. OK, great. Now let's go through an exercise of building all these things from scratch. So I've shown you what happens once everything is run. Let's really see what it takes to make this happen. How, in my opinion, how easy it is we try to offload the whole configuration process from our customers by making it really simple and seamless for them. So let's just go to an analysis. Once you're in analysis, let's just load in a time series chart, like on date and revenue. As you can see, this is a simple line chart. It has a linear trend that is going up. The data is also seasonal. So going here, to start with, once you load a time series over here, QuickSight, if you can see this side pane over here called Insights, once you click on it, QuickSight automatically runs through a bunch of insights on your data, like runs through a bunch of computations on this particular chart, and comes up with some insights that it thinks could be important to our customers. As you can see, there's a period-over-period change. The time granularity is day, so it's a day-over-day change. What your lowest day was, what your highest day was. We also run anomaly detection on this particular time series to tell you, hey, there are some things that are happening in your time, like a line chart. So you might want to take a look at it. We also, there's year-to-date, there's month-to-date, and all these kinds of analysis. Now let's go to what it takes to set up an anomaly detection job that we just saw in the previous tab. Now, all it takes is to click on this button, which says Add Anomaly to Sheet. Once you click on this particular tab, you get a new visual, which says Configure Anomaly. Now, you want to go to your field wells and drag the columns on which you want an anomaly detection. In this particular case, let's say I want to do it on product categories and geo. Once you have this set up, you click on Get Started, and it shows you, OK, I'm running this on a time series data where your time column is date, your value is revenue, and these are the two categories that I'm running with. In QuickSight, you also have the option to run this in a hierarchical mode or you can just run it on all possible combinations of the categories. So I'm just going to click on analyze all combinations because these two are not really related. Like you have something like city, state, like state, city, zip, that becomes more of a hierarchy. Here, product, category, and geo are kind of unrelated, so you can just help us analyze all the options. So you click on, you can also create a schedule here. You say, I want to run this daily based on how fast your data is refreshing in the backend. And then you select a time and the schedule has to run in your time zone, and you're done. That's it. And you click on run now, and the anomalies, the magic is happening in the background. So QuickSight, our backend systems get a request, and we start running through the anomaly detections. Now, while this is running, I want to show you what it takes to actually get forecasts in QuickSight. Like I briefly touched upon the fact that you have a trend here, and the data is also seasonal by weekly. Now, all it takes to run to create a forecast in QuickSight is to click on this button and say add forecast. And QuickSight goes on. So what QuickSight really does here is it tries to understand three things. What really goes into creating a forecast are three components: trend, seasonality, and error. So we go about estimating these particular concepts within QuickSight and constructing and deconstructing and reconstructing this forecast data for customers. Now, provided some customers may want to tweak some of the configurations such as seasonality. Like for example, we might assume the data to be seasonal every 7 days, whereas the customer might think I want this to be bi-weekly or monthly. So we give the option for customers to really go and configure the data seasonality here. And you can also say how much in the future I want the forecast to go. This is 14 periods. You can change this to 20, 30, or whatever, so on and so forth. All right. So it looks like the anomaly detection was run. So all it takes now is you click on this and say I want to explore anomalies, like we did in the previous few tabs. And now you can look at here, show me my anomalies. You can just say, okay, there seems to be like 25 anomalies here, and you can just go in and see that there are spikes, your data spiked here. It's pretty much the same thing. You click on a point, you can analyze contributions, and so on and so forth. I also want to talk about another feature that we launched along with anomaly detection and forecasting, which is the natural language insights. Now, all it takes is, to write something over there is basically.
You want to
create a new visual?
Yeah.
Yeah, sorry. So all you can do here is go here, click on plus. We automatically pop in a visual for you, and then you can go in and say customize narrative. In here, you can go on and say, hey, I want to add growth rate into this. I want to see what my growth rate was for the last 7 days. All you have to do is go here, add computation. You come in here, you click on growth rate, you say next, say I want to do 7, and I say add. Now, once growth rate is added, you can say something like growth rate for the last 7 days was and we also have the option to add inline if, so you can embed some code, and based on certain values, you can have these decisions taken on the UI on the fly. So you can say I want to add an inline if. If, let's say, your growth rate was less than 0, say, can do better, right? However, if it was, let's say, another block which says if it is greater than 0, great job. Now you can format this in any such form you have. You can bold it. You can also change the color, and you just click apply. Now, based on how you configured this, the narrative automatically gets reflected over here. So you see the growth rate for the last 7 days was 0.19%. Great job, because it was greater than 0. So that's kind of the thing that we're trying to target, these new features that we recently launched. To wrap up before, I want to just go about talking about the, sorry. Yeah. So, yeah. So let's talk about what really happens in anomaly detection. We use an ensemble-based technique using decision trees. So we have a random, like a forest, and within the forest we train multiple classifiers, like you have trees. So our premise is multiple weak classifiers, the trees, combined together form a strong classifier. So what really happens here, we do a bunch of pre-processing within the customer's data. We don't expect the customer's data to be fully clean. We agree that the data can be sparse, the data can have null values. So we take it on us to go through a whole process of cleaning the customer data before we run through all these analysis ourselves. So when we're trying to reduce the false positives as much as possible. So as you can see, we basically give you directionality on the, so customers can look for higher than expected, lower than expected. They can filter by these things, and they can, there's outlier clustering where we cluster customers' data smartly in order to show that, hey, your anomalies occurred on this particular timestamp, and not show, like basically try to reduce false positives. So I just wanted to show you some experiments on null data. So as you can see in the chart that is on the left, right? So you have null data over here. Like over here, there are gaps in your time series. But when you really see the forecast on that particular data, we've ensured that we impute those null values with what the normal should be at that particular point, and then give you a clean forecast. And you can also see here on the right side, it's actually a patient's heartbeat that we have captured. It's basically a repetitive pattern of every 185 points. As you can see, there is some sparse data in between. I mean, the patient is still alive, but it so happened that there was some data which didn't come into the system or any of that sort. We really take into consideration all those points, and we give you the forecast over here. And finally, I wanted to do a comparison between our forecasting algorithm and the traditional state space models like ETS that you have off the shelf that you get. So on the top is what QuickSight's forecasting algorithms are, and at the bottom is ETS. So if you can see in the presence of anomalies, QuickSight still performs well. We filter, we weed out the anomalies, the bad apples that you can call, and the forecasts are not affected. Whereas in ETS, when you start seeing anomalies, your forecast starts to get impacted, right? Like it starts coming into your forecast. Similarly, as you can see, the more anomalies that come into your system, the greater the change in your graph is. Like ETS gets confused in the second chart. On the third chart, as you can see, the gap between every period has reduced in the last 3 periods at the top. So QuickSight uses an unsupervised algorithm where it is actually learning the pattern in your underlying data. So as and when your time series pattern changes, QuickSight adapts that and gives you a forecast suitably. Whereas as you can see, ETS kind of gets confused. With statistical models, sometimes you see this particular problem. Finally, before I close out, I also want to talk about sometimes in QuickSight, we may not get the seasonality correct. There could be a plus or minus, you could be off by 10 points, right? When you're off by 10 points, the forecast really is not affected that much. That's what I'm trying to show here. So even when you change your seasonality between 183 and 187, the forecast is still tight. It's not that, it doesn't vary that much. Whereas in other models like ETS, as we see, it's kind of going up and down all over the place. So stability is also very important when you come to anomaly detection and forecasting, so we do that as well. So that was all we had to present from the ML features that we have in QuickSight. If you want to, so these features are in preview, so if you'd like to sign up, please go to this particular URL anytime from now and sign up. We're looking forward to hear from you all. Thank you.